So can AI write a good bash script for a Unix system? Well, we're going to answer that question today. Yo, what's up everyone? My name's Dave and you suck at programming. And today we're going to look at a script that's been written in AI. In one of my previous videos, I issued a challenge for people. I said, you know what? You guys are using AI to generate scripts. Send one over to me. Email it to me. Let me take a look at it. Let me review it and critique it in a video. And one person has stepped up to the plate, okay? One person actually sent me an email with the script, and today we're going to look at that script. This script is called cleanup.sh, and it is a very simple bash script to go through and clean up large files on a file system. So it looks for files over a certain size and then gives you the option to delete them, or at least that's what it looks like it does. We're going to dig into this and see what's going on here. All right, first things first. First thing I noticed is your bang here, /bin/bash. I would change this to user bin env bash, because I don't know where bash lives on a system. On most systems, it's going to be in /bin bash, but it might be somewhere else. In fact, on my system, you can see, let's do a type-a bash. It actually is in user bin first, and then it's in /bin second. That's kind of weird. Why is that? Well, because on my system, well, if we look at bin is actually it's easier to read it like this. Read link bin is a symlink to user bin. All right, so it just so happens to be in bin bash. That will work on my system, but you could be on systems where it might not be there. So first things first, make that change. And then, cool, we have a bunch of functions here. So nice, the script makes functions. That's super nice. So we can call all these functions. Let's go to the bottom of the script where these functions are actually being called, or at least that's where I assume they're being called. Jump to the bottom of the script, and what do we have here? Main script starts here. Show disk usage, find large files, and we give it an argument of 800. I don't know what that is, but let's read this comment. You can change 500 to any other value to find files larger than that size in megabytes. So it looks like it's the size of megabytes, but look at this. We already have a discrepancy between what is in the code and what is in the comment. That sucks. You should not be duplicating information between the two. The comment should explain the code, but it shouldn't just reiterate it completely. So it looks like this is the size of megabytes. The code is 800. You can change this value to any other value to find, or this number to any other value to find files. Change it to something like that. That way, whatever you change the number to makes sense. And if it's not a number, then we know it's wrong because it doesn't align with the comment. Cool. Then we confirm, then we select the files, then we perform cleanup. Awesome. So let's start with the first function, show disk usage. Jump up here. Cool. Current disk usage, we just print df-h. If you've never seen this, it's a super simple command. This just shows disk usage on your system. I have a lot of stuff going on here, just ignore it, but it shows disk usage. So hopefully this might be useful, but if you have a lot of disks, that might be a lot of information. Then we jump down here, find large files 800. So we go up to find large files, finding files larger than $1 megabytes. Okay, so 800 megabytes. Find /, so this looks in every single directory on your system, files, type F, size plus 800 megabytes. And then for every single file, we exec ls, and then we do LH, and then what is this? Whatever the argument is. Actually, I think find does batching, so it might not be for every single file, but regardless, we're going to run ls with a long listing and human readable output, and we're going to discard any errors that come up along the way. So right here, this is an interesting command, and I'm going to look at this. So I'm going to take this command, I'm going to copy it. Nope, I lost it. All right, I'm going to take this command, I'm going to copy it. This is what you get when you try to mix mouse and keyboard. And there we go. We have this command, find type. I'm not going to find / because it's going to be a lot. So let's look at something like var. And let's change this to anything over 50 megabytes. So let's look for files over 50 megabytes in var on my system. Uh-oh. That's a lot of files. What happened here? 2.81 megabytes, 25.4 kilobytes, 54.2 kilobytes. Something's not working here. So what's going on? Well, that's interesting. Let's take a look at this. We have -size with find. Let's look at find. Do we have -size with find? We do. Size, true if the file is n blocks long, 512 bytes per block. If n is followed by a c, the size is in bytes. It doesn't say anything about m for megabytes, so what's going on here? Well, I'm not going to hold you guys in suspense. I'm just going to tell you what's going on here. This isn't the find you expect. You're expecting GNU find. This is not GNU find. We are not using GNU utilities. We are on a different system. We're not on Linux. We are on SunOS. Look at this. So this is running on the Illumos kernel. So this is based off of the Open Solaris project. It was forked from there and forked into Illumos. So we are not on Linux. Find doesn't have those arguments. So this is just something to be in mind. So for my system, this wouldn't work. This script would not work as is because it assumed GNU extensions on find. What do we have though? Well, I have find. You just have to put G in front of it. If you're on a free BSD machine, you might have something similar. So let's just toss G in front of this. I'm not going to hold it against the script because this will probably work on a Linux system. It's just not going to work on mine. It's not fully portable. So just be mindful of that. All right, let's go down here. Confirm cleanup. What happens here? Read, do you want to proceed? So we read user's choice, and then we have three possible things. If they give us a Y or a capital Y, we proceed with the cleanup. If they give us an N or a capital N, we clean up aborted and then we exit. And if they give us any other input, we call confirm cleanup again. So a couple things here. First of all, look at this. See this green highlighted area? That's extra white space. The machine learning algorithm wasn't trained on the bash man page. It was trained on a bunch of scripts. And a bunch of people have trailing white space and garbage in their scripts, all right? Garbage in, garbage out. Pretty simple. So let's get rid of that trailing white space, and then let's think about this. So if we give it a Y, we'll proceed. If we give it an N, we'll call exit. But if we give it any other information, we'll call confirm cleanup. So this will call itself. See any problems with that? Well, let's look at something really interesting here. I'm going to toss something in here. Let's say there's a built-in variable, I haven't talked about this on my channel, called funcName, and it's an array. So we're going to count the length of the array. We are levels deep. It's kind of weird, right? So what's going on? What are we going to do here? Well, let's make some changes here. Let's change this to var. This way we won't find anything. And let's just run this. So what's going to happen when we run this? It's going to ask us to confirm. Finding files larger than 800 megabytes. Do you want to proceed with cleanup? Let's give it something other than Y and other than N. Let's give it an A. Hit enter. We are 2 levels deep. Let's give it another A. We are 3 levels deep. Let's give it another A. We are 4 levels deep, 5 levels deep, 6 levels deep. What's happening here? What's happening is every time we give it an invalid response, we are recalling the same function. We're not going to the top of the function. We're calling the function again. It's being nested. It's being pushed onto the stack. Our stack right now is 43 levels deep, and 42 of those are probably the call to confirm underscore cleanup. If we were to give this a bunch of invalid input nonstop, we'd crash the program. We would crash the shell. We would get a stack overflow. We'd blow out the stack. That's exactly what would happen. So how do we fix that? That's kind of lame, right? Isn't that kind of weird? What do we do here? Really simple. What we can do is we can put this in a, let's do a while true do. So we put all of this into a while loop. Let's put a done here. My indenting is all wrong. This is using 4 spaces and I like to use tabs. That's what's happening here. And then let's say if we got an invalid response, we want to do nothing here. And if we get a valid response, we want to break. We want to break out of the loop. This is unfortunately hard to read. Let me put some line breaks in there to make this easier to read. There we go. Hopefully this makes it easier to read with some of these line breaks. All right, so now we just have an infinite while loop. And what we do is if the user gives us a yes, we break out of the infinite while loop. We don't need to reconfirm their input. If they give us a no, we abort and we call exit, so we're already broken out of the while loop. And if they give us any other response, we don't do anything, which brings us back to the top of the loop. We haven't created a new function. We're not going to blow out the stack. We've just gone back to the top of the loop. So that's pretty cool. That's a way of dealing with that. So let's go back down here. Confirm cleanup, select files for cleanup, and perform cleanup. So select files for cleanup. How do we select files? Please enter the full path of each file you want to clean separated by space. It just showed you large files. It expects you to copy and paste them back into the script. The script knows about these large files, but it wants you to pull in the files that you want to delete and separate them by spaces. See anything wrong with that? File names can have spaces in them. They can have new lines. They can have anything but a null byte or a slash in them. So this will break on a lot of different file types, okay? We shouldn't be asking the user to put these files back in. Maybe we should number them or give some sort of identifier that we can then ask. Maybe we could just have a whole list of them and ask the user to confirm. But right here, I just don't like the way this is doing it. And then right here, we check if it's a file. So because we're checking for large files and then deleting them after, there's inherently a race condition here. The file could be removed in the time that you run the script. The only way to guarantee this wouldn't happen would be like take some sort of snapshot of the disk, which I could do because I'm running on ZFS, but for Linux, you might not have this. I don't know about Linux on ZFS. Either way, we check to see if it's a file before we actually don't do anything. We just echo. That's all we do is we echo. That's because the next function is the one that actually RMs it, and it also checks for a file. So for each file we're going to delete, we have to stat it twice just to make sure we actually delete it, even though RMing the file will generate an error if the file's already not there. Very un-Unix-like. And for a Unix-based script, I don't really know. There's a lot of stuff that I would just clean up with this. With this, I'm not even going to bother trying to clean this up. I would just rewrite it from scratch. If you're actually looking for large files on a system, learn these commands. I would just say learn how to use find and df and du. Learn these commands yourself, and then you won't be trying to write these generic scripts to do everything. You'll just be able to run simple commands to kind of problem solve. So there you go. That's my review of an AI script.